Hello friends, in this video let us try to solve a very simple problem on first order Markov source. Now this is the first order Markov source diagram which has been given, and what do we observe? That there are three states 1, 2 and 3. And what are the probability of these three states? The probability of these three states is given to be 1 by 3, right? So therefore it has been given that P of 1 equals P of 2 equals P of 3 equals 1 by 3, right? So that has been given here, and then it has also been given that if we are in state 1, then what happens? The system remains in state 1 with a probability 1 by 2 and also emits a symbol A. Now if it is in state 1, it goes to state 2 by emitting C with a probability 1 by 4, and similarly from 1 to 3 by emitting a symbol B with a probability 1 by 4. Now similarly, if the system is in state 2, continues to remain in state 2 by emitting the symbol C with probability 1 by 2, goes to 1 by emitting symbol A with a probability 1 by 4, and goes to state 3 by emitting B with a probability 1 by 4. And the same thing happens for state 3, right? So remains in state 3 with probability 1 by 2, emitting symbol B, goes to state 2 by emitting C with a probability 1 by 4, and goes to state 1 by emitting A with a probability 1 by 4, and this is what has been given in the problem. Alright, now what do we observe? Now first of all, if I consider the states, the probability of the system being in state 1 or 2 or 3, if I add up the probabilities of all the three, that is P of 1 plus P of 2 plus P of 3, it is equal to 1. Next, if I add the probabilities of the transition from state 1 to 1, 1 to 2 and 1 to 3, it is also equal to 1. Alright? Now how is it 1? 1 by 2 plus 1 by 4 plus 1 by 4 is 1. Now similarly from state 2, 2 to 2, 2 to 1, and from state 2 to 3 again is equal to 1. 1 by 2 plus 1 by 4 plus 1 by 4, and similarly from state 3 to 3, 3 to 2 and to 1, it is again equal to 1. Alright? Okay. So what is the first thing which is being asked? The first thing which is being asked is we need to find the entropy of each state. Now how do you find the entropy of each state? The entropy of each state is given by this expression. Now the entropy of state I is H of I equals summation j equals 1 to n Pij log to base to 1 by Pij bits per message symbol. Now if it does look complicated, it isn't. So let us try to find the entropy of state 1. Now what is the entropy of state 1? I have H of 1 equals, how many states are there? There are 3 states. So j will vary from 1 to 3, P1j log to base 2 1 by P1j, which is nothing but equal to, so here j varies from 1 to 3, which means P11 log to base to 1 by P11. So for the first case j is 1 plus P12 log to base to 1 by P12. So what is j? J is 2 here. Plus P13 log to base 2 1 by P13, j is 3 here. It essentially means I'm actually finding the entropy of the state by considering the probabilities. That is, from state 1 to 1 is P11, P12 and P13. Right, so now I guess you got how to find the entropy of the state. So H1 is equal to, what is P11? It is 1 by 2 log to base 2 1 by 1 by 2 plus P12 is 1 by 4 log to base 2 1 divided by 1 by 4 plus 1 by 4 log to base 2 1 divided by 1 by 4. So this is nothing but 1 by 2 log 2 to base 2 plus, can I write this as 2 into this term? So 2 into 1 by 4. So this can be written as log 2, log 4 to base 2. Alright, so this is 1 by 2 into 1 plus 1 by 2 into 4 can be written as log 2 square to base 2. And this is nothing but 2 log 2 to base 2, which is equal to 2. So I have into 2. So this is 1. So I have 1 by 2 plus 1, which is 1.5 bits per message symbol. So this is H1. So can you tell me what is H2? Now H2 will also be P. So here 2, 1, J is varying, right? So the first number is fixed, which is 1 here. Here it will be 2. And J varies from 1 to 3. So P21 log 1 by P21 to base 2 plus P22 log of 2 1 by P22 plus P23 log to base 2 1 by P23. Now what do you observe? Again, P21 is 1 by 4, P22 is 1 by 2, P23 is 1 by 4. So you get the same values, isn't it? So I get 1 by 2 log to base 2 1 by 2. So here I get 1 by 4 log to base 2 1 divided by 1 by 4 plus 1 by 2 log to base 2 1 divided by 1 by 2 plus 1 by 4 log to base 2 1 divided by 1 by 4. So you find that these two are one and the same here. Alright, so therefore the value is 1.5 bits per message symbol. Now can you guess what can be H3? Now H3 will also be 1.5 bits per message symbol because, so let me write H3 here. So H3 will also be the same, isn't it? Because I get the same values, I have the same values. H3 is P31 log to base 2 1 by P31 plus P32 log to base 2 1 by P32 plus P33 log to base 2 1 by P33. So what is P31? P31 is 1 by 4. 3 to 1 is 1 by 4. Log to base 2. Can I write it as 4? So it's going to be 1 divided by 1 by 4, which is nothing but 4, plus 1 by 4 log to base 2 4 plus 1 by 2 log 2 to base 2, which is again 1.5 bits per message symbol. So what have we done? We have actually found out the entropy of each state, which is H1, H2 and H3. So to find the entropy of each state, what do you consider? You consider the probabilities of the transition, that is from state 1 to 1, 1 to 2 and 1 to 3 for H1, 2 to 1, 2 to 2 and from state 2 to 3 for H2, and 3 to 1, 3 to 2 and 3 to 3 for H3. So let me write it in this way. So H1 equals H2 equals H3 equals 1.5 bits per message symbol. So this is the first part of the question. The second part of the question is to find the entropy of the source. So how do you find the entropy? The entropy of the source is given by this expression. So here I have H equals I varying from 1 to 3 because there are only 3 states, Pi, Hi. Now what is Pi? Pi is nothing but the probability of the individual state. So I can write it as P1 of 1. So therefore the probability of each state, so P1 is nothing but 1 by 3, P2 is again 1 by 3, P3 is also 1 by 3. So H equals P1 H1 plus P2H2 plus P3H3. So P1 is nothing but P of 1, P2 is nothing but P of 2, P3 is nothing but P of 3, and all of them are equal to 1 by 3. So here I have 1 by 3 into 1.5, because H1 is 1.5, plus 1 by 3 into 1.5 plus 1 by 3 into 1.5. So I can take 1.5 common, I get 1 by 3 plus 1 by 3 plus 1 by 3, which is 1.5. Again, bits per message symbol. So we have found out the entropy of the source, which is very easy. Okay, so now the next part is we need to find G1 and G2, and then I need to compare it with H, and we need to prove that G1 is greater than G2 greater than H. Okay, now what is this H S bar? Now H of S bar is nothing but the entropy of the adjoint source. Okay, so the adjoint source is defined as a zero memory source which has the same source alphabet and the first order probabilities as the initial state. So the probabilities as the initial state is what is considered for H of S bar. So now if I consider the second extension, which is H of S bar square, this is how we represent. We'll have to consider the source alphabet and the second order probabilities at the start of the second symbol interval and so on. So how do we do that? We shall see. So we need to draw a tree diagram. So here let us consider the initial states 1, 2 and 3 with the probabilities of the system being in state 1 of 1 by 3, state 2 1 by 3, state 3 1 by 3, and what are the respective symbols, which is it is A for state 1, C for state 2 and B for state 3 as given in the figure. Now let us assume that I move from state 1 to 1. I am moving from state 1 to 1. So what happens? The symbol probability is 1 by 2, and what is emitted? A is emitted. So finally what do I get? I get A, and what is the probability here? I need to multiply 1 by 3 into 1 by 2, which is equal to 1 by 6. So I need to use these probabilities for calculating G2. Okay, so let's first complete the tree diagram. Now 1 to 1, then I have 1 to 2, and then I have 1 to 3. So what is the probability of the symbol here? So 1 to 2 is C with a probability 1 by 4, and 1 to 3 is B with a probability 1 by 4. So here I have 1 by 4 into 1 by 3, which is 1 by 12. Again this is 1 by 12. And what about the symbol? The symbol here would be AC and AB. For the next one, 2 to 1, 2 to 2 and state 2 to 3. So 2 to 1 is state 2 to 1, probability is 1 by 4 and A, the symbol being emitted. 2 to state 2 is 1 by 2 with C, and 2 to 3, state 3 is B with probability 1 by 4. So here I have 1 by 3 into 1 by 4, again it's going to be 1 by 12, here it's going to be 1 by 6, and here again it's going to be 1 by 12. And what about the symbols? It's going to be CA, CC and CB. Alright, so this is the state at the end of the first symbol interval. So now let us consider from state 3. So I have 3 to 1, 3 to 2 and 3 to 3. So 3 to 1 is A with 1 by 4. 3 to 2 is C with 1 by 4, and 3 to 3 is 1 by 2 with, of course, B. So here I have 1 by 12, 1 by 12, 1 by 6. And what about the symbols here? So this is BA, this is BC, and this is BB. So this is the state at the end of the first symbol interval. So this represents the initial state A, and here you have another symbol which is being emitted, which is A. So I get AA, AC, AB, CA, CC, CB, BA, BC and BB here. Okay. So now what happens to find G1? So the general expression is Gn 1 by n summation PMI log 1 by PMI, of course, to base 2. And if you are in the initial state, that is stage 1, so here n is equal to 1, here n is equal to 2, I definitely have to find the entropy. So for G1, what should I do? It is going to be 1 by 1 into, I need to consider the initial state, 1 by 3 log to base 2, 1 divided by 1 by 3 and so on. So that is 1 by 3 log 1 divided by 1 by 3 to base 2 plus 1 by 3 log 1 divided by 1 by 3 to base 2 plus 1 by 3 log 1 divided by 1 by 3 to base 2. So I get 1 by 3 log 3 to base 2. I have 3 of them. So it is essentially log 3 to base 2. So log 3 to base 2 would be 1.585 bits per message symbol. Okay, so this is nothing but G1, or you can also refer this as HS bar, of course to the power of 1, which is not required. So HS bar, which is nothing but equal to G1, is this. So you find that G1 is greater than H. So what was H? We did find the value of H as 1.5 bits per message symbol. Alright, so now to find G2. So now you know how to find G2. So to find G2, what is n? The value of n, of course, is 2. 1 by 2 into, what probabilities do I need to consider? I need to consider these probabilities. The probabilities here. Right? So the probability which includes the initial state and after the end of the first symbol interval. So these are the probabilities. Alright? So let me count how many 1 by 6 is there. I have 1, 2, 3. So can I write this as 3 into 1 by 6 log to base 2 1 divided by 1 by 6. I am skipping a step. So instead of writing this term 3 times, I have written 3 into this plus, how many 1 by 12s are there? 1, 2, 3, 4, 5, 6. So 6 into 1 by 12 log to base 2 1 divided by 1 by 12. Alright, so I get 1 by 2 into, this is 1 by 2 log 6 to base 2 plus this is again 1 by 2 log 12 to base 2. Alright, so do not forget this 1 by 2 here, else your answer would go wrong. So therefore we get the value as 1.5425 bits per message symbol. So this is G2. So what do we observe? G1 is 1.585, G2 is 1.5425. So definitely G1 is greater than G2. which is of course greater than H, is what you need to check in the third part of the problem. Okay, so what have we done? We have actually found out the entropy of each state, that is state 1, 2 and 3, which is very easy. Find H1, H2 and H3 by considering these probabilities from state 1 to 1, 1 to 2, 1 to 3 and so on. Next, entropy of the source. We just have to multiply the state probability into the entropy of that state. Right? So the probability of the given state into the entropy will give you H. And of course to find G. So to find G1, of course you need to consider the initial state. To find G2, you need to consider after the emission of one symbol. So therefore you have the initial and the first symbol which is being emitted. So finally you get these values and you calculate the probabilities by multiplying these probabilities of, I can say, transition or the symbol probabilities, right, into the state probability. So you get these values. So you consider these values and you find the entropy, and do not forget to divide by 2 to get G2. And we find that G1 will always be greater than G2, will be greater than G3. Now sometimes in your examination they will also ask you to find G1 greater than G2, greater than G3, greater than H. So you need to show that G1 is greater than G2, greater than G3, greater than H. So we have found out G2. So what do I do to find G3? So to find G3, again, I am in state 1. So again I can have 3 more, right? State 1 to 1, 1 to 2, 1 to 3. So what is 1 to 1? The probability is half. So here the final probability would be 1 by 3 into 1 by 2 into 1 by 2. So that is 1 by 6 into 1 by 2, which is 1 divided by 12. And what do I get? I get A. So I need to complete this for the entire stage. Okay, right? So I would get how many values? So 3 for each. So here we got 9. So there we would get 9 into 3, which is 27 values of probabilities. So you get 27 values of these probabilities. Again find the entropy and divide it by 3 and you will get G3. And you will observe that this relation will definitely hold good. So I will leave that as an exercise for you to do, okay, which is very simple. Just extend it further. You will get the probabilities, find the entropy by considering the probabilities for the next stage, and then divide by 3 and you get G of 3. So this is how we solve problems. So this is a very standard problem which keeps coming in the examination. Of course sometimes you may have variation in these values. Instead of 1 by 2, 1 by 4 and 1 by 4, you may get some other values of probabilities of these transitions. So keep that in mind. You just have to remember these 3 formulas and you will be able to solve the problem very easily. Right? So remember that solving any problem under Markov source first order is very simple. So keep practicing and I hope you will be able to solve every problem correctly given in your examination. Do not forget to like, share and subscribe and press the bell icon to get notifications of all the further uploads, and thanks for watching.